Alright, so welcome back again. So in this wonderful and exciting tutorial, we're trying to see how to build a simple project and build a simple application using machine learning, right? And then you'll be following through the machine learning life cycles, not using LLMs, but using traditional machine learning. So let's see what we're building. So what we are trying to build, and the problem I'm trying to solve, is that we have a blog here. Then inside this, our blog for our website, see, we have our website with a forum or a blog, right? And then for every blog we can have multiple comments, right? So people can just give comment on it. What we want to do is that we want to train a model that will be used to check and analyze the comments that people are giving for every post on the blog, and then we will know whether it is offensive or not offensive, whether it's a hate speech or not a hate speech. Of course, we can do a lot of things with it. We can do a lot of classification. We can just do offensive offensive or not, right? We can also do sentiment analysis. We can also do any form of text classification, right? On it. So we can train different models to analyze the comments that people give on our blog or on our forum, so that we will know which of them we should pick or which of them we should not pick, right? Which of them we should ban from the platform. So how do we do that? So there are several ways you can do that. You can use a large language model to help you do that, or you can just follow through the traditional ML procedure, right? So let's see how to do that. So the traditional machine learning lifecycle is that you collect data, right? And once you have collected the data, that is the first step. You do some data cleaning and data preparation, and then after that you do feature engineering. That is the next step. So feature engineering is that you are going to convert the data that you have into useful insight that you can use for other stuff, right? You're going to extract all the useful insight from the data. And then there are two ways. In most of the case, after doing feature engineering, people just move straight away to model building. But a better approach is that after you have done feature engineering, you store the feature, right, into a feature store, right? So we have Feast, we have feature store, and then you can just store it there so that you can use it anytime you want to build a different kind of model, right? Because data is very, very important. Just like a refinery, you have to refine it to get more important benefit. Then we build our model. And after building our model, we have to interpret our model, because if you want to create such a system in which you decide whether a comment from someone on a post, on a blog post, is offensive or not, or you want to give the sentiment of it, you need to understand why it is offensive, right? So you have to do model interpretation. That is the next step. So there are several tools we can use. So there is several ways you can work on it. You can just use Eli 5, you can use Lime, you can use Sharp, right? You can use Dayless. There are so many tools. And inside a model interpretation, you can also do, based on the type of model we can have, we can also do something we call bias detection, right? Bias detection, bias and fairness detection, right? Which is very important, right? Because sometimes you have to know that your data set is balanced and then it's not biased, right? Very important. And then after you have finished building your model, you have interpreted your model, you can do model 7. So the model 7 is, you can save the model as a package, right? As a standalone package, like all the large language models, that is a standalone package, or like an API, something like you save the model behind an API so that you can expose it to different forms of services, which is very useful, like OpenAPI and then Croc and all of these things. And then there is also, you can also embed your model directly into a web application or any interface, right? An embedded system like a phone or like the Google Lens and stuff. And then finally you do monitoring. So the monitoring, you are monitoring your model together with your application, together with the service, and then you are also collecting data. So this is another step you should also remember. When you are monitoring your model that you're saving, you should also collect data again to use to train your model, right? Because there can be data shift or model drift, right? So let's see how to follow this approach to build a wonderful model for this particular application to be built later on. So I'll go back again to my workspace here. here, and then I have my data here, and I'm going to open with Jupyter Lab, right? So in case you don't have Jupyter Lab, you can just install it, and then I will copy this. Yep, I'll copy. It does automatically open in my other browser, but I'll copy this, and then we will open it. So I'm just going to open a browser so that we just work on it, right? Perfect. So that is what we'll be doing, and as you can see, we have our task there, right? Perfect. Okay, so let's see how to build this our wonderful model from scratch. So we'll be going through the steps, and then we start with our task, right? So the task that we'll be building is that we're going to be doing a test classification of, let's say, comments using ML, right? And then the main idea behind this is that we want to train a offensive or hate speech, right, detection, right? We can just do a lot, not just one. We can do emotion classifier, we can do several, one of them, right? So they are different, etc. So let's start with it. So the data I got from GitHub, and then we start working on it. So let's go back here, and then let's go with this test classification of comments using ML, right? We also use the deep learning. Okay, so let's start with this. I'm just going to load my EDA package. Then I'm going to import pandas as PD, and then import NumPy as NP, and then we will also need to load our data visualization packages, our data vis packages, right? And then we will use it for our tasks. Perfect, right? So these are the two main packages we're using, so pandas and then Seaborn, to help us visualize our data. Then let's load the data. So df then pd.read_csv. Then I'll go back again to my dataset, which is my hate speech dataset, and then I'll preview it, right? So all this we are doing, as you can see, all this we are doing is we are still doing data collection. We have collected data already. We want to do data cleaning. So let's start with it. As you can see, it has been categorically encoded, but I don't need these ones, right? Which is okay. I can use it to make my work easy, but I only just need the class, right? So let's see how to get it back. This is going to be my df. Then I just need the, I can just go df columns to list it out. I only just need this side, the class and a tweet. That's the only thing I need. So that I have it in a simple way, right? So let's see how the data is. Looking at the data, there is a lot of cleaning we are supposed to do, right? To make it better for us. So we can also check the class, which is also encoded. But in case you want to make it easy for us to understand, we can also add another label to it to make our future self know what each of these values mean, right? So what do we mean by 0 or 1? So this is how it is. So this is a class label. So there is hate speech, which is 0. There is 2, 1, 3. So if I check this one here again, and I do df to the class dot unique. If I go with this, you can see that we have these values, and then I want to map them, right? So in case I want to map them, I can just do, say, class labels, and I'll just go with my df. The simple way that I can just go with my class and then dot map, then I can just pass in here. So this is not correct. This is, if I go with this, right, our data set has integers, but we want to map them well. So to map it, I can invert this dictionary, and then do something like this. So this is going to be something additional like this. So my value and k, so for k and then v inside my class labels dot items, and this is going to map them all. So now if I go back again and I check the classes, so class target class, right? If I go with this now and I check this here again, you can see that now we have this as this. But if I do my labels and I check it again, you see I have it perfectly well, right? Perfect. So we have seen how to do some simple encoding of the classes. Now let's move on from here and then let's do some data cleaning. So it's going to be, before we do, we can just do by class distribution plot, and we can just simply do cborn dot count plot. I'll pass in my data. So data is going to be my df, and then the target is going to be my class labels. Now you can see how the data looks like, and based on this you can see that this is not balanced, right? So from this picture you can see that the data is not balanced. We want to make sure that it is balanced. If we use this, it will classify most of the data as offensive, right? Because this is the highest. So we have to balance this data set, right? So let's see how to do that, right? So first, before we can simply, there are several ways we can balance a data set, and one of the ways we can balance a data set is using, as I said, I can just show it here. We have two methods. We have undersampling and oversampling. So based on the data that we have here, you can see that it is the offensive labels is higher than the rest, right? So we can oversample this, increase this to here, or we can undersample this, right? That is what this image is. So we can do undersampling and then oversampling, right? So undersampling means that you have the original data set, then you sample the majority class to be smaller. Oversampling is that you have the minority class and then you keep copies of it to make it like the majority class, right? But in our case we will do an undersampling. So let's start with it. So how do we, before we do undersample, let's do our data cleaning first, or we can just, let's do data cleaning, right? And this data cleaning here, we will be, first you will just remove stopwords, and then we remove all the hashtags, tags, all the unnecessary characters, special characters, and then what we want to do is that we also want to remove punctuations, right? There's a nice library that we can use to help us with that, which is called JCharisTech. That comes with all of them already in bulk. So let's start with it. So going to be import JCharisTech.functions as NFS, right? And then with JCharisTech, if I go with this NFS, you can see that it has so many methods, so many functions we can use to clean data, right? We can remove accents, we can remove barcodes and the rest, right? You can remove hashtags, you can remove HTML. As you can see from our data, we have some hashtags in the data, right? So these are all hashtags, we can remove them. You can move all of these things, which is the names from them. We can clean them, right? So let's see how to simply do some simple data cleaning. So I can just go with this, and then let's simplify it. So I'll call it as this here. I have my data, and in case I want to remove all the stopwords, I can just go with this option. And then in case I also want to remove, let's go back again. I don't want to remove punctuation, but in case I want to remove hashtags, I can also do the same thing. So remove hashtags, right? And then I'll just go back again, and it has removed all the hashtags. So if I compare the two of the data, you can see the difference between them, right? You can see how it is, right? You can see the difference of how the data is, right? So this was here, and some of the hashtags have been removed from it, right? We can also remove these names, Twitter handle name, which I don't know how it is called, but to remove multi-space hashtags, remove material. We can also remove special characters, right? You can remove punctuations. So let's see how to also remove the rest. I'll copy this. There is also a pipeline from that you can also use, right? So let's remove punctuations. And then we remove finally all the special characters. Then if I go back again, hopefully it is cleaned well. Now it's better, right? You can see that this has been cleaned well. This is the old one, which is still there, and the new one is well cleaned, right? Very cool. Okay, perfect. So now we have cleaned the data somehow. We can now build some models from that, right? Okay, so that is it. So let's first of all build a model. So after here, right, what we need to do is, we have done the data clean. We can do feature engineering, in which we can just convert our data into vectors, right, and then use them and then store them somewhere. Or we can just build a pipeline. Here we can simplify this one by building a pipeline, right, that will have a transformer, right, and then an estimator. So a transformer is one that takes in data and then produce data, right? So data to data. And then an estimator takes in data, then it produces a model, right? So that is a basic understanding. So a transformer takes in data and it does some stuff to it and then converts it to data. An estimator takes in data, then converts it to a model. So we build a pipeline and then use it for our activity, right? So let's see how to do that. So it's going to be my ML. So let's say build a model. Right. So what we do is that we use a pipeline, as I said. The pipeline will have a transformer. So in our case, our transformer is going to be we can have count vectorizer, we can have TF-IDF, we can have embeddings, etc. Right, to transform our data from one format to another format. And then we will have our estimator. So our estimator here can be all the different ML algorithms, right? So we can have naive Bayes, we can have logistic regression, we can have SVM, all of them. So that's what we need. So let's first build it, right? So we will just go back again, and I'm going to specify my features. So we have the features and then the labels, and then we will split our data, right? So before we split our data, we will just go back again and I'll import all the ML models, right? So that they need to type them, and then we will first of all split the data set. So how do we do that? We can simply do this option here. We can just split it, right? So we are splitting it into 70% for the test and a random state of 42, and then we're going to return our result. Perfect. So let's build our pipeline. So let's make a pipeline. In most cases, you should have a base pipeline, right? So we will have 3 different algorithms and then 3 different pipelines, right? So we are using count vectorizer. You can use TF-IDF, which is also another estimator. So you can use TF-IDF if you want. So let's also create one for TF-IDF. I'll just pick this one, and then I'll just call it as loss regression TF IDF. Right. And I'll change this one to TF IDF, and I'll call it as TF, right, IDF. Perfect. So we have some models that we can use. I think I forgot something. So loss regression, pipeline. Let's see. Yep. Okay. So the issue is here. So we have steps. We have TFI. We have forgot this. Yeah, perfect. So we have our pipeline that we have built, right? So we pass in the data. So the idea behind the pipeline that we pass in the data through the transformer to the estimator to return our model, right? So data to data, data to model. Okay. Let's see how to build our base model. So you will first of all have a base model, right? And then with the base model, we will determine what is going to be our accuracy. So this is our base model. So this is our pipeline. We have our count vectorizer and then our dynamic classifier, right? Just to have an idea of how good the model is. Then we will check the accuracy of this base model. So we can do that with pipe base dot score. Then I'll pass in score. I'll pass in S test and then Y test. And this is it. So this is the base model, right? 77, right? Which is not good. So we should be assuming that our model should be able to be above this, right? So this is the base. So 77. But you have to notice that the reason is 77 is that this data set is imbalanced. So most of them is going to be offensive classifier. Let's go on and then let's repeat it for the other models. So let's build one for A base. So A base model, which is going to be the same thing we did here. But this time we will not go with this approach. We just call it as my naive base, right? And then we can also do the same thing here. So naive base, and then we can specify the score. And this is it, right? So now if I take off this, it is 85, right? So 85, which is better than this one, so that means it's good. I can also repeat the same for the logistic regression. And then let's see that. So this is LR, and as you can see, the pipeline is built. See, we have the count vectorizer and then the loss regression. And if I check the score, this is also better, right? You may be thinking it's okay, but you have to understand that it is predicting offensive more, right? Okay, now let's do the other one for the TFID. It's going to be my LR TFIDF and then LR TFIDF, right? So this is a different approach, and this is what 88, right? So how do we make a prediction, right? So you have built our model. We want to be able to, before we want to interpret, we want to predict, make some prediction with it, right? To see if it's working. So let's check it. We can do make a prediction. So I'm going to have some example of tests there, and I'm going to just make some predictions, right? So let's say we need some just simple test. What I'll do is that I'll just ask an LLM So I'm asking an LLM to build something for me. Yeah, and then let's see. It's funny. I have some example here, but it's funny. So this is right, and then this yeah. Okay, so right, so these are bad ways. So let's see if our model can predict them, right? So to make a prediction, I can just do my pipeline, right? So let's use the naive base dot predict, and then we can just pass in our value. So we can simply do something like this. So for I in test, you want to make our prediction, and then I'll pass in the print I, right? Or we can simply do just this option here is better. The print, then, or we can just go with this strings all the way. Okay, and I'll pass in my I here, I'm passing another one, it's going to be my I here. So let's see, so this is f string, and let's see. So you can see I don't know why it cannot predict well, because I have to change it from here till here. And then this is supposed to be in the format of a list, right? So I pass in the I. Yeah. And now you can see that this is so bad. Why did you do this, idiot? This is offensive language. I swear this is also offensive language. Let's put something that is not an offensive language. So this is not offensive. So let's see if the model will detect. So you can see that this is predicting this one as also offensive, right? So why is it doing that? Let's try another model. You will try another model using the logistic regression. It's also doing the same thing. The logistic regression model was better, right? You could see that it predicted the first one as neither, right? This is so bad. Why did you do this, idiot? And this was offensive, which is offensive. I love coding too much is neither. So the LR model, logistic regression model, was better than the naive based model. We can also try for the TF-ID, and that also was also somehow better, right? But you can see that in all the case, this is always seen as offensive in all the model, right? So the model is very good at determining offensive language, but the rest, sometimes it fails based on what you are using. So we can choose the logistic regression model, right? And you can say this is also this is not correct. So how do you fix it? So there are several ways you can do that. So the first option is, first you have to interpret the model to see why it's making that prediction, and then you also have to check if there is an imbalanced data set, right? So let's see, first of all, let's fix the imbalanced data set, right? So as I said, you can fix an imbalanced data set by doing oversampling, right, or undersampling, right? And there are several methods you can use to do that, right? But this is beyond the scope of this course. But let's see how to do that. So simply we can just use scikit-learn. There's a library called Imbalance, which can also use to help you. It's called Imbalance, right? Imbalance. You can also use Imbalance, but SacredText also have some utils to help you do that. So that's what to be using. So let's go with from SacredText sklearn.utils import a sample, right? So we're using that particular library to help us. If I go back and I check my class labels, but value count, you can see that one of them is bigger. This is bigger than this one, right? If I multiply this by 100 and I divide, or let's divide before we multiply. I want to divide the entire stuff by the ship, which is the ship, the first value of the ship, but it's the number of columns. You can see the percentage, right? And I multiply it again by 100. You can see that the offensive language is 77 more, and then neither in the hit is too small. So we want to reduce this, right? We want to undersample this. So how do we quickly undersample without using any external library? So we can simply do that by just using resampling, right, to help us with that. So let's try it out. What I will do is I'll come back here. You have my data is here. I would want to pick this column and then split them, right, per the respective one. So this is something simple to help us with that. So what I'm doing is that I just picking number 1, number 2, number 0, right? And I'm specifying them. So the offensive one is number 1, and then the neither is number 2, and the hate speech is also 0. So if I go with this option now, I can get the shape. So if I check for the shape of this, you can see that this is the amount. And if I check for the shape of the majority, which is more, I want to reduce the majority to be something like this, right? Around this spot, or maybe 5,000, right? So in that case, I can simply do something like this. I can just go with my df majority undersampled. Then this is going to be my resample from SacredText. Then I'll pass in my majority class. Then I'll specify the number of samples I want to put. So this is this amount, right? I can just make it 5,000 instead of, at least so that it's better. It's almost close to this place. And then I can just say replace is equal to false, right? So that means that don't replace any of them. And then I can specify the random state of 42, right? So in this case, what I'm doing is that I am resampling this majority. I only just want 5,000 instead of this 19,000, right? It can also be the same as this. And then I can just say, don't replace them. So I can make this one the same. Let's make it for 5, right? This is okay, right? Not 5,000, at least a little bit higher. And this is going to resample them. After it has undersampled them, I can now concatenate all of them together, right? So now I want to combine all the minority together using PD concat. I'll pick the minority, I'll pick the undersampled, and I'll pick the hate speech. And now if I go back and I do df balance, right? If I go back with the same option here, let's copy this, and then we will plot it. So now it's better, right? So 18, 18, 5, right? Which is okay, right? We can also plot this. In case I want to plot this, I can just do sns.count plot. I'll pass in my data, which in this case is df balance, and then s is going to be my class labels. And now this is better, right? So at least we have pages almost neither offensive and then a h. We can also oversample this, make the h speech higher, but yeah, let's keep it like that just for now. So in case I also want to increase this, all I have to do is, instead of resampling, I'll just go in place true and I'll specify the value, right? The minority class. So this is going to be this, and then right, sample and then replace, right? Perfect. Okay, now since we have done this balance splitting, let's go back again, split our data, and this is going to take us some time. Sometimes I prefer to always do it this way and then build functions and then call the functions, right? Because it's always better to use functions than this, right? So now we will be using the balance. Right, and then we can now build our models again. So I'll not change it, I'll just operate in the same approach. So let's pick this. What I would do is this is okay, but I can make it like this. So B for balance, B for balance, B for balance, and B for balance, right? So that at least it's separate from the other one, and then I can just go back again, B, B, right? And you see that this is 80, but the previous one that we had, which was, sorry, this is 85, right? 85. We can also repeat it. This is 85. The base, we can also do the base one to see that. And let's go to so this is 80. B for balance, B for balance. You can make the name explicit, right? Yeah, and then we have 85. We can do the other one for logic regression. So 85, right? So 85, 85, which is okay. And then let's make our prediction as we did earlier on. If I come back here and I do B, so now the naive base is better, neither offensive, neither, right? It's better than the other one. It was not predicting, it's now predicting it differently. If I do the same for the regression, we have, yeah, this is okay. This is a hate speech. It's failed. Funny how this failed. And I love coding. This is okay, right? Yeah, it's funny how the models behave. So that sometimes you need more data to be able to TF-IDF. Perfect, right? So this gave all of them as neither, right? So based on how the data is and based on how much you train and based on how much you prepare your data would influence your model, right? Now let's see how to interpret the model, and then we see how to save it and then move on to the other aspect. So all this I'm doing, right, we can simplify it using a system so that whilst I'm building and testing, I can use a system like MLflow to track, or ML track, right, to track the parameters and the changes, so that I know which of the models is good and which of them is not good, and then pick the best one, right? Perfect. You can also do model evaluation, which is something I also forgot about. You can, after building, you can also do evaluation here. That's where we check the score, you check the classification and the rest, right, to know all of them. So in that case, in case I want to do this model evaluation, and then the next one will be interpretation, right? So in case I want to evaluate it, I can simply just pick the model that we have done so far, all the different models we have done. I can simply do this. So my Y predict, and let's pick one. So pipe naive Bayes, then predict S-test, and then I'll just go with my print. I'll go with my classification report, and I'll pass in my Y test. So my Y test and my Y print, right? We can just use this approach to do some evaluation. So the reason is saying that vocabulary not fitted or provided. So yeah, I'm surprised it's giving us this, right? Let's see. Yeah, because we changed it. So now we have a model evaluation. So you can see the hate speech, the precision for all of them. The hate speech, neither an offensive language, their precision, their record, the F1 score, right? And then the different accuracies. Perfect. So this is one way I can just do. The other one for logic regression, which is also different, right? Perfect. So based on these things, you can pick which of the models are useful for your task. Okay, let's do some model interpretation. So how do you interpret this model? So as you could see, we were able to get some predictions here, right? You're able to get some predictions in our test here. Now, how do we interpret our model? So interpreting our model, we can use libraries like, as I said, we can use Eli5, we can use Lime, we can use Sharp, right? We can use Taylor's, we can use several of them, etc., to help us interpret the model. So this is our prediction. Let's go with the loss regression. This is our prediction. Perfect. But in case we want to interpret why it gave us these kind of predictions, we can just use a simple library to help us do that. So let's see a simple example of model interpretation. So I'll go back here and then I'll import my library. So from lime test, there is lime tabla. I want to import my test explainer. So there is lime test explainer because it's a test. And then I will specify all the classes. So we already have my target class here, which is this, right? So this is my target class, right? So let's to list. Yeah. So I'll copy this as my class names, right? So that we have it here. Right, perfect. And then I will want to create an explainer. So first we have to create an explainer to be used to explain our model. The explainer is going to be my line test explainer that takes in my class name. So class names, go to class names. Perfect. And then once I've created an explainer, I will now combine it. So explain my instance, and I'll specify the particular instance I want to explain. So let's say this is hate speech, right? So this is the first one. So in other words, if I go back to pipe lrb.predict, the first one was test. This is supposed to be inside a list for it to work. This is a hate speech. Why is it giving us hate speech, right? So we can just copy this information can now pick this example one here. We want to explain why is it that. Then we specify the model that we are using. So dot predict prober, and then we specify the number of features, right? The number of features can be the pipeline. Sometimes you can just go with the pipeline that there is, based on whatever it is, right? But I can just specify some features there. Let's say 100, right? But mostly it's there. Inside here, we created a vectorizer, right? And inside this vectorizer, we built some features. So we are using those features for this number of features here, right? But I can just keep it as 100 for now. And then in case I want to list all of them, can do as list, and it's going to list all of them based on the feature weights, right? The weight for all the test it's gathered during this step. This our vectorization, converting the test into numbers. That is the weight just given here, right? All of them here. And then in case I want to visualize this, and say show a notebook, and I'll pass in my test with my example 1, and then I'll pass in my labels. Let's pass in just one of the labels. I can also give in multiple labels, and as you can see, I don't know whether you can see it well, but let's change the settings, the theme to a light theme, so I can see it well. You can see the prediction, right? So this is offensive language and then offensive. So offensive language and not offensive and offensive, right? And this is the prediction probabilities. So neither, based on our prediction, this was predicted as hate speech from here. This was hate speech, as you can see, and this is the test there. This is so bad. Why did you do this, idiot? And it's telling us from our interpretation the percentage for all of them. So neither, offensive, and then hate speech. The sum total of this is what is going to be used for this probability. So we have some on the right, some on the left. So this is so bad. Why did you do this, right? So bad and do are for offensive, right? So the reason it's saying it's offensive is because there is bad and do, right? But idiot is non-offensive. I don't know. It's funny, but I think it's because of the color. So it's so bad, so bad. Why did you do this, right? That's why it's giving us this prediction as offensive. Perfect. Which is I'm surprised. The interpretation can be so funny, right? Funny. Okay, we can also plot this, right? So in case you don't want to, you want to see it in a better way, we can also use this approach to plot it, right? It's another way. So what we are doing inside this function is that we are getting the list as an ordered list. We are getting the weights for each and every of these keys there. Then we are using Seaborn to plot it. So this is we convert this into a dictionary and then we plot it, right? So we can just come down here and then pass in my plot explanation, pass in SP, and then we have it here, right? So this is exactly what you are seeing here, right, in a simple way. Okay, so we have seen how to interpret our model. We know why it's giving us these things. We can do more. The next thing is to save the model, right, and then save the model, right? So model saving and model saving. So how do we save this model? Right, so most of the time there are several packages. We can use JobLib, we can use the library itself, right? There's ons, ons. Yeah, this is, yeah, this is open standard for machine learning network exchange, which is a very useful standard for saving machine learning models, right? So they can use this option. It's not ons, it's oms format. You can also use pickle, but it's not recommended, right? And then you can also use TF5. You can save it even in JSON. You can use H5. You can also use let's say Keras, in case you're using deep learning model, or TF format, right? So there are different formats you can save your model for, right? But you'll be using JobLib for our case. So let's go with import JobLib. And then most of the time there are several ways you can save your model, but I prefer to always save it using a simple approach, which is easy for me, for my future self, to remember, right? To know. To know it. So this is how I do that. What I do is that I pick the model that I'm saving, so the kind of model I want to save. Then I give it to NBCV, right? H speech classifier, and then the date, right? And I'm using pickle, right? As I said, but you can also use any other format. Then I can save the better model. So let's save the proper model that was good, which was LRB. Right, so you're saving the LRB, which is a balanced one. That's what you're saving. So once I've saved it this here, I can now package it for my API, right? So since I've saved it, I can now package it for my API. I can build it or use a different tool for that. And then we can also do monitoring for the model, right? Using Labs or any of these tools. So I can show you what I mean. There is also, right, which is a very simple library we can also use to monitor your model, right? Which is very cool. You can also use MLflow to also monitor your model, to trace them. So there are several tools you can also use to help you with our task, right? So thank you for watching the tutorial. So in the next session, we'll try and see how to save this model. So in case I want to save this model, I can quickly come back here. Let's go back here. And you can quickly build a simple model to fix it, right? You can simply use FastAPI or any of the libraries. Come back here, I can just make a directory, and I can just create apps, go into apps, and then I can just create my app.py. You can use Streamlit, you can use any of the libraries. Code app. I can simply build a simple library. right? So we can simply build something like that. So first, in case you don't have Fast API, I can just go back with pip install Fast API and then UVCon, right? Or you can also use Streamlit, any of them, right? Any of these libraries, and then you can just go back again and we can simply build it, right? Build something very simple for us to do the prediction. So you can just go back here. Just go from Fast API, import my Fast API, and then we can simply go with my app. It's going to be my Fast API, simple, and then we can just load the model. So as you saw from here, we had this option here, right? So we can just do the same thing. We can pick this model that we have, specify say the model, model path, which is going to be my, let's call it as os.path.join. Then I'll just pass it here, right? So something like this. We need to import os, and then from here we can let's create a directory called models where we put a model here. So this is going to be models, right? Something like that, or we can just perfect, right? Then once we create the model, we can also go with import joblib. Then we can just load the model. So let's load the model. It's going to be my joblib.load, and I'll pass in my model path. Perfect, right? So let's build a simple classifier with Fast API. So I call it as app, but I can call it as API. Anyhow it is, it's okay. So API def. We can make it async, right? Async def, then predict. Now pass in the data that I want to pass there, right? So there are several ways we can do that. I can just use a Pydantic model. So from base model, then I can, this is not needed, but you can also work on it, right? It's not needed. I just create my class base model, then this will just go with my test string. Then I can just pass it here, the data that I want to predict, test data. Then I can just do try. We get the test from here, whatever the test we are getting, right? We get a particular test, and then we just do my prediction. Going to be my model.predict. Then I'll pass in my data.test. Right. So this we get a prediction. Then we can also do the prediction probability. So probability. So model.predict proba. Now do the same thing, data.test. Then I can just return something like this. I can just take off the triceps. We will work on it later. Just return a dictionary, right? Yeah, something like this. So this is simple application I have built. Then I can just go with my API dot. We can make it post. Predict. Perfect. So that is all. So this is a simple way we can actually save application. And in case I want to run this, right, I can go back again. So this is a simple application. I can just go back UVCon, then the name of the app. So UVCon, the name of the app was app as the name of the file, right? Then I'll just create my app or API. So what you're referring to is, so the name of the app and then this API. Reload. Yeah. And then we can just give the port of, let's say, 8,000, right? Hopefully it's not listening on the same port. Now let's run it. This will fail because, yeah, it's working, but we don't have the model yet. So we have to go back again and then pick the model from here. And you have to pick the model that we had, this one. Go back to our apps and then place it there, right? So that it can see it. And then it said it's failed, right? No such file. So let's go back again. Let's reload and then I can open it. So it's giving us an error. So this is the error it's giving, job lab with some information with the pickling. So that's one of the reasons sometimes it's not advisable to use pickle, because it can just fail over some very simple stuff, right? So the different NumPy version, because of a different NumPy version. If I take off this and then I take off this, let's take off this. Wait, 10. See? Nice to have it here, and then we can actually return some stuff there, the text that we wanted. So something, and then it's supposed to return, right? But as you can see, we have built a model, right, on the same system, but because of a NumPy version, it's not able to build, it's not able to show the result, right? So that's why sometimes when you're building an application, you should always ensure to use the right library, right? Because we use pickle, and now because we use pickle, it is failing. Right? So let's go back again and ensure that sometimes we closed it. So I'll go back here to here. So this was it, right? So this is what we used, and somehow, for some reason, it's failing. So funny. Just copy this one. The best approach is you have to virtualize your environment, right? Virtualize it so that you serve it well, right? So the same environment you used to build, you serve it well, or use ons, as I showed you. You can use ons to save it so that you don't need to worry about all this unpacking stuff, right? So you can just use the ons option here. So this is ons, and then with ons you can simply save it, right? So it's maybe another time we do a tutorial on how to use ons for our stuff. So thank you for watching this tutorial. I hope you have learned something. So there are several ways we can, and now we can build a machine learning model. So after building a model, since we have built a model, we have built an API, we can now expose our blog to those tests, so that anytime a test is sent, a comment is sent, it says post to the endpoint, the API that we built here, which is trying to load, right? And then it gives a prediction and the rest, right? So that is something that I wanted to share with you. I hope you have learned something in this tutorial. So thank you for watching the tutorial. See you in another session. And during monitoring of your app, you can also collect data back, right? Using MLflow. So thank you for watching. See you another time. Stay blessed.